This set of slides will be about the transuranium elements, which basically means the ones that we made with particle accelerators. Our lesson objectives will just describe the synthesis of transuranium nuclides and talk a little bit about what they do. Okay. So this brings us to the topic of nuclear transmutation. So a transmutation reaction can occur via decay or via reaction of a nucleus with another particle. So we can do either fusion or fission. So basically any time the nucleus changes, it's a nuclear transmutation. Okay, so an example of that from work that was done by Rutherford, he took the stable form of nitrogen, nitrogen-14, and he bombarded it with an alpha particle to make oxygen-17 and a hydrogen atom. Nowadays, we've made a bunch of elements using particle accelerators. So in a particle accelerator, you smash the atoms and particles together at or near speed of light to create heavier elements. So we're talking a lot of energy. On the left there is a picture of the Fermilab. So it's been decommissioned, but it was a particle accelerator outside of Chicago. If you look, you can see in that picture there are parking lots with itty bitty cars. To give you a matter of perspective, the radius of these things is about a mile. So they're very large and they produce very high energy particles going very fast. So it turns out we've made a lot of synthetic elements using particle accelerators. To date, 26 have been documented and confirmed, and they all have symbols on the periodic table. So the most recent one was the OG oganesson, I think it is. Anyway, everything in purple is only observed if we use an accelerator to make it. The stuff in pink is only in trace amounts naturally. And the stuff in red or orange is naturally occurring and extractable. Okay. So all of those purple ones are completely synthetic elements. We made them with particle accelerators. They don't exist, as far as we know, otherwise. It would take really, really big stars to make them. All right, so this brings us to the transuranium elements. So what is this concept? Anything over uranium with a Z, an atomic number of 92, is made via a particle accelerator. It is a synthetic element. There are 26 transuranium elements out there. So the ones in purple on that periodic table I showed you earlier. All of them are made with fusion reactions. In all of them, you smash your rather large element together with something smaller. So you can use neutrons and really big things, alpha particles, carbon-12, oxygen-18, chromium-54, iron-58. You notice that we're going up, up, up in the mass of the things that we're smashing together. In some transuranium elements, we have to use other transuranium elements in order to make the new one. So, for example, nobelium right in the middle there with an atomic number of 102, you have to take californium, which is already a transuranium element, and you have to smash it into carbon-12. So, this is not a trivial task, and we're interested to see what happens because we're filling out the periodic table, but also we get a new appreciation for how the sun works when we do this, which is kind of cool. To summarize, nuclear transmutation occurs whenever you change a nucleus, which can be from fusion or fission. Particle accelerators are used to make the synthetic elements. There are 26 transuranium elements where Z is greater than 92, and all transuranium elements are made with particle accelerators, some of them with other transuranium elements.